Ammonia is oxidised as shown. Which whole number values for W, X, Y and Z balance the equation? So there's a couple of ways you could approach this. You could almost do this by trial and error. So you could look at this equation and see that there are 3 hydrogens on the left and multiples of 2 on the right, and try to find a common multiple. So you could say, well, if I get this to be 2 and then 3, that they both multiply to 6. If you do that, you'd need to put a 2 here, because to make the nitrogens balance, you need to have 2 nitrogens on each side. If you now add the oxygens up on the right, you've got 5. And if you then do the oxygens on this side, you get 5 over 2. Now it says whole numbers, so this would be 4. If I double everything, 5, 6, 4, which is answer C. So I've done it one way, that way. I could, because it was oxidation, I could have done this as what is happening to the ammonia is it's going to NO. And I could have looked at this and seen that I could have balanced the half equation. So I could have added a water on this side and then added 3, not 3, there's 5 in total, 5 H pluses on this side and 5 electrons. And then I could have done the oxygen in a similar way. Oxygen's going to water. We're going to balance that. 4 H pluses and 4 electrons. Now, if I'd have done this, I would have seen that in order to get them to combine, I would have had to times this equation by 4 and then this equation by 5, which would have already given me that I had 4 ammonias and 5 oxygens, which led me to the answer C as well, even if I didn't finish off the rest of the combination of the equation. So there's 2 different ways. If trial and error isn't working for you, maybe think about taking it back apart into the redox equations, because you could have completed this, multiplied them out, added them together and cancelled and got the equation that you needed, which would have given you the full answer.